And then tonight, you're part of the event. Your involvement, your feedback is going to give information to Scott as he makes his presentation on the information that he already has for writing the book with its AV aspects to it that's going to take two years to get done. The intention is to present over 18 weeks, 9 one year, 9 the next, bits and pieces of science from one perspective or another. We started off already with the Big Bang, a single topic area. We're going to do something similar to that through the next 2 years. But tonight is exceptionally exceptional in that he's not going to give you an index list of what he's going to talk about, but rather he's going to tell you why he's talking about it, what the meaning is behind the whole series in the first place, and how that affects you in your naturalistic philosophy and your humanist life. Scott, I want you to live up to that.
Good evening. Thank you for showing up. So I've been deeply inspired by the fact that when I was in junior high, I got to watch Carl Sagan's original Cosmos series. On Sunday evenings, I would go into my parents' bedroom and sit on their bed and watch Carl talk about science. And I'm not certain that that was the beginning of my passionate, lifelong, so far, love affair with science, but it was certainly instrumental. And I haven't stopped. I studied science in college, and I've continued to learn about scientific topics ever since then. And I have a slide about this a little later on, but I want you to understand that I don't presume to be an expert. I think I know quite a bit, having read quite a bit, and I try to do the best job I can to ensure that what I read and what I integrate into my view of reality is consistent with the best information that science has to offer. I'm sure that I make mistakes. I'm sure there are all kinds of questions I don't know the answers to. But because throughout my life I've been able to think about and learn about things that are divorced from a very narrow specialization, I've gotten perhaps a relatively unique perspective on the way that scientific topics integrate with one another. And this 2-year series of programs will cover what I hope is an integrated set of topics about science, why science is important. And with each topic, I hope to cover something that is surprising or something that may dig a little deeper than you might be accustomed to thinking about or learning about as you watch a typical television program or read a general science book. As Jack indicated, I started off talking about the Big Bang in not this coming Sunday, but the third Sunday of this month at 9:30. I'm going to talk about the lives of stars and the story of gold. There's 96 naturally occurring elements. I can't talk about all of them in an hour, so I picked one that I thought most people would be interested in. We're going to talk about gold. November, why math is important to science. I don't intend to do a lot of mathematics per se. There's not going to be any homework during this lecture, but it's a curiosity at least why math is so relevant to science. We're going to talk about that. The fourth is measuring the world. What does it mean to do science? What does it mean to gather data? And what are we gathering data about? Then moving into Einstein's relativity, which you probably have at least a familiarity with the term. I hope to talk about it in a way that makes it more concrete. And quantum mechanics. I don't think anybody can explain quantum mechanics effectively because it's weird, but I'll pick out some of the weird aspects and try to convey them. And then we're going to talk about symmetry theory. This is something I've been studying for the past couple of years. May seem kind of like an odd duck in this list. Many of you may not be familiar with it. This is an elegant approach to understanding why different things in the different quantities that we see in the universe, like mass and momentum and charge are conserved. And where does that conservation come from, and how does that relate to mathematical quantities? After that, talking a bit about particle physics, the stuff that makes our visible universe, and then wrapping up this year in the spring with a talk about cosmology. Next year, I want to move beyond basic physics and talk about theories for the origin of life, something called abiogenesis, how life arose from things that weren't living. Natural selection and evolution, once life got started, what happened? Then DNA, genetics, and a relatively new science of epigenetics. And then bio and nanoengineering. I hope you can see I try to make it kind of thematic here. And then taking another significant shift, once advanced organisms, intelligent species such as ourselves have arisen, how do we live well together? What does it mean to live well? Some theories and topics from political science and liberalism. Then we're going to talk about economics, another favorite topic in my household. I think that it's often given short shrift in scientific discussions, and I look forward to being able to talk about it, hopefully dispel some illusions about economics. Then talk about critical thinking. How do you recognize poor or illogical or irrational thinking? Following that, the practice and practitioners of science versus pseudoscience. And then wrapping out this series with great unsolved mysteries. What do we know about that we haven't yet solved? And what are some hints about things that are unknown? We have no data about it, and we don't even know sometimes the right questions to ask. So that will round out. Now, there's a lot of stuff about science that's not on here. There's no geology, there's no climatology. I've done a little bit of study in linguistics. All kinds of topics didn't make it on here, but hopefully I'll be around more than a couple of years, and we'll see where we go from there. So that's the overall program. Why am I doing this? Well, here's a bit of philosophy for you. Philosophers make a distinction between positive and normative statements. Raise your hand if you know what that means. Okay, a couple of you, so I'll spend a little bit of time explaining it. So a positive statement in philosopher speak is not, you're a good person. That's not a positive statement in this context. It's also not the kind of positive we talk about when we talk about the charge on an electron. Positive statements in the philosophy of science are statements about what is. Statements that tend to be verifiable. We can make positive statements about the world. You have mass. The sun has a particular temperature. The earth has a particular size. Any factual statement about the observable world is a positive statement. Contrast that with something called normative statements. Normative statements take the form of, what should we do? What should the world look like? Should the world have more forests or more parking lots? That's a normative question. And the answer to that is a normative statement. And scientists are often fairly careful to stay on one side of this issue versus the other. Another way to characterize it is the is versus ought problem. And this is the way that David Hume explained the problem back then. So the idea that science, often and scientists, practitioners of science, try to stay on the what is side of things, and many times intentionally avoid the what ought we do kinds of statements. Like, what ought we do regarding the Earth's climate? What ought we do versus biodiversity? What ought we do versus genetic engineering? And one of the reasons that humanism appeals to me is that although I'm very interested in science, I'm also interested deeply in the ought problems, as I think are you as well. And I believe very strongly that in order to come up with the best answers to the questions of what ought we do, what kind of world ought we live in order to answer those most effectively, we need to understand the world. So this is the statement that's the sort of the subtext for the Quest series that I'm going through, and this is what this is my conviction. This is why I'm doing this. To live well in the world, albeit the term "well" it might be open to interpretation, but to live well in the world, we must understand it. We can't just make stuff up. And that's why I think science is important to humanism, and I think that's why science is incorporated as a pursuit of natural philosophy and a natural view of the world, naturalistic view of the world, that is explicitly espoused in humanism. Ways of understanding. So there are other ways of understanding the world. Stephen Jay Gould famously, he wrote a book where he said that supernaturalism and science might be non-overlapping magisteria, that they each have their own realm of pertinence and relevance. And many people agree with that. Many people like to have kind of a picket fence down the middle between their scientific views and their views about mystical happenings in the universe. I don't tend to be one of those, and many of my friends don't tend to believe that this separation is meaningful. One of the problems is when you talk about supernatural, well, if you see something happening in the world, if we all watch a ghost walk in and shake my hand and then float through the wall, that will necessarily be a part of the natural world. It becomes immediately amenable to scientific analysis and scrutiny because it's seen to exist in our world. So from that perspective, there's no such thing as supernatural to begin with. Everything that we see, everything that we experience, if we can verify that it's true, it becomes a part of the natural world that we have to explain. And when I talked about the Big Bang a couple weeks ago, I tried to emphasize how surprising it can be to learn about the natural world. When you look at the stars, to recapitulate a bit, when you look at the stars across generations, they don't seem to change, they don't seem to move. It's quite reasonable and logical and rational to say that the universe is composed of a bunch of stars that never change. Why would we ever assume anything different? Because when we look carefully and we measure carefully and we look across vast distances in time, the universe surprises us with the variety of phenomena that it exhibits. And we don't have to imagine fairy tales to be surprised by the wonders of the universe. If we have a ghost come in and greet us and move through the wall, then that's another surprising aspect of the real universe, and we should be able to test it and verify it and experiment on it. Supernaturalism, one of the most basic forms, is animism, the idea that everything has a spirit. And if it has a spirit, what most people mean by that is it has a set of intentions. It has a set of desires. A rock desires to not be broken apart, perhaps, right? And I believe that science sometimes misuses this intentional kind of language when describing phenomena, when it says things like, the rock wants to roll downhill. I think we buy into this too easily, this idea of animism and intent in the natural world. Theism is another supernatural belief. The idea that there are gods and that they're weird, right? They're unpredictable, they're chaotic, they're malicious, they're benevolent, they need blood sacrifices, whatever the case may be. A bunch of strange ideas come along with the notion of theism. Humans as superstitious pigeons. I believe it was B.F. Skinner, Dave?
Yes.
Yeah, Skinner. Yeah, B.F. Skinner. Have you heard of this experiment with the superstitious pigeons? So put pigeons in a box, something in an environment, and he would give those pigeons food pellets at random times, completely randomized. And the pigeons would notice that they'd be walking along, and they might look to the side, to the right side, right before a food pellet comes out. Well, the pigeon that did that would say, you know what? Maybe if I do that again, I'll get another food pellet. And it started exhibiting learned behaviors that were acquired randomly because it correlated what it did to the way the environment behaved around it. And humans can exhibit the same kind of supernatural tendencies. If we dance a certain celebratory dance right before a thunderstorm, maybe one thing had to do with the other, right? So this idea that we are inherently programmed, not just human beings, but nearly any life form with a brain is programmed to look for causal relationships between what they do and what happens in the world, that is so deeply ingrained that you have to consciously overcome it. And that takes work. It doesn't happen automatically. Cause and effect, and intentionality. So this gets back to what I was talking about before. If you see something happening in the world, it must have had a predecessor, an antecedent. If there's a tsunami in India, maybe it has something more to explain it than the fact that we live on a planet with shifting tectonic plates. It was so egregious and grievous and malicious and horrific for so many people. It was easy for other people to assume that that happened because of some malfeasance on the part of others, or maybe on the part of the victims. And that kind of looking for causal relationships, looking for intent where there is none, is another trap that you can fall into unless you use discipline to understand the natural world, unless you recognize that sometimes stuff happens. And then magic. So we know that there are magic practitioners that have a lot of personal integrity. Dave and Shiloh, my family, my selected family, and I are particular fans of Penn and Teller. And Penn and Teller are very upfront with the fact that when they're doing a trick, they're fooling you. They don't pretend to do anything mystical. They don't pretend to violate what are otherwise recognized properties and phenomena that happen in nature. Other magicians, they go by different names like faith healers. They go by names like, I'm going to offend some people tonight, by the way. They go by names like chiropractor or Reiki practitioner. Other people who participate in that kind of magical thinking would want you to believe that they have some capability to overcome natural or biological processes through some unexplained and fundamentally unexplainable set of practices. This kind of magical thinking can be quite entertaining, but it's not science, and it's baloney, typically. What's the alternative? Naturalism. So again, this is part of the humanist creed. Nature has verifiably true sets of properties and behaviors. You can go back and drop a rock as many times as you wish, and that rock will reliably fall. There is a vanishingly small, in fact so small that we call it zero, chance that when you drop a rock it will jet off to the moon. And we know this, and we know the way airplanes work, and we know the way brakes on our automobiles work. And science has informed us well enough that we can use the flow of electrons to turn on lights and to operate video cameras and projectors. We've done all kinds of potentially what might be called magical things, except that they use known, repeatable, demonstrable aspects of the natural world. And this idea of verifiability, rather than anecdotal stories, if I told you that I saw a ghost last night, well, you might initially believe that I'm a credible witness because I tend to be a scientific skeptic. But that shouldn't constitute proof. You should require that that ghost show up when you're there or when a video camera is there. So personal stories are not enough. And the brain can be easily fooled. These truths hold across space and time for naturalism. We have mechanisms within science to verify that when electrons jump around in hydrogen atoms and emit light, the way that happens in our light bulbs on Earth is the same way it happens in a galaxy 15 billion light years away. Right? We have clear evidence that the laws of nature are the same here and on Pluto and in a distant galaxy. And in fact, that sameness plays into what I was talking about earlier with regards to symmetry laws. The very existence of that kind of symmetry in natural processes necessitates certain conserved quantities. That means necessarily that there will be aspects of the universe that don't change through space and time. Naturalism believes that phenomena are likely to conflict with our biases and preconceptions. Right? We will be fooled. You look out at the sky and it seems static and unchanging, but the universe has fooled us time and time again. We don't just live in a solar system. We live in a galaxy. We live in a cluster of galaxies. We live in a supercluster of galaxies. We live in an observable universe that is almost certainly a small fraction of the amount of stuff that came into existence during the Big Bang. And that vast amount of stuff is just one instance of a Big Bang. And if a Big Bang can happen in the manifold of space-time once, then likely it's happened many times. So these biases that we have, like that Earth is a special place, or our solar system is special, or our galaxy is special, these biases are continually refuted. So another thing about supernaturalism is that there is no repeatable, verifiable evidence. It's random. Whereas naturalism, we have copious and clear evidence, and it's highly predictable. And remember, our goal is to understand the world. If we want to be able to answer the questions about what ought we do, and we want to be able to say, well, if I push or pull over here, what's likely to happen over there in the future, one of these frameworks for understanding the universe seems far more likely to give us the information we need to take intentional action to make our world a better place. The other one, it's a crapshoot. If magic is real, why does it matter what we do at all?
Scott?
Yeah.
Just a thought, a question. Earlier you said, there are unknowns and unknowns. Mm-hmm. Are you saying those are now confined or put in the box of naturalism?
Yeah, well, so let's take something that...
You know what I'm saying? Are you putting yourself in a box that any unknown discovered has got to conform to the rules of what we know from naturalism?
Generally true. I have a bias towards believing that. However, if we do see something that violates our prior knowledge about the way the world works, then we have to change our model of reality. We can't presume to let our biases and preferences dictate the way reality works. If we find something completely new, we have to incorporate that as a part of the natural world. And that's how unknown unknowns can change our view of reality. 100 years ago, the fact that the universe, the expansion of the universe is accelerating was unknown, and nobody was even asking the question. But once we discovered that that's true, we had to change our fundamental view of reality. Right? That's a cosmic level question, but there are other questions on a smaller scale that entail that same kind of thing.
I guess the reason I brought it up is that's kind of the world that supernaturalism lives in, the unknown unknown.
Yeah, but they make claims about the real world.
Okay.
When you talk about in astrology or Reiki or other kinds of things, they make real claims that this will make you better or that this will lead to fame and fortune. And unless you can verify that, it's not an unknown unknown. It's a known lie.
Okay.
So dogmatic truths. We're going to talk about dogmatic versus provisional truths. Dogmatic truth says, hey, look, I've got these nice truths for you. And they need not be internally consistent. because they're mystical. You'd better not poke and prod at them too much because these are the truths. And I'm telling you they're the truths, and everybody in the neighborhood's telling you these are the truths. And because I say it's the truth, it's the truth. And you're just going to have to trust me because, well, you have to trust me, or else, right? So if you don't trust me that these are the truths, then, well, you know, I pity you because, shut up! Stop not trusting me. Okay, now I'm going to have to shut you up. All right, I'm going to have to take some action to make sure that you agree with my point of view. So this is what dogmatic truths tend to do. Well, what's the other alternative?
Science is full of provisional truths. I think I may have found something.
What do you think? Do you see it too? Hey, let's see if others can see this same thing. Like, I just found that neutrinos can travel faster than light, and I'm an Italian scientist. This happened a couple years ago. And the whole physics world was like, okay, I don't believe it, but let's try it out. And they found out that it wasn't, in fact, true. But let's try it. Let's see if it happens. Hey, we didn't think of that. When you discovered that phenomenon, maybe you left something out, or maybe your model of it is incomplete. All right, let's make some changes to this view of reality. And you know what? This probably isn't the final answer. The world probably isn't flat. You know, an atom probably doesn't look like a little solar system. There probably aren't angels sitting in every cell of our body dictating the way that those cells should behave. We probably don't have the final answer. But we can explain a whole heck of a lot with the answers we do know, and when we change them, they tend to be provisional and incremental changes, not whole cloth changes. Let me give you an example. I've written about 20,000 words on this topic preparing for tonight. I thought maybe I'd stand up here and read it to you, but I decided to go this route instead, and the stuff I've written will go into the book that Jack was mentioning. But one of the examples that I came up with is, you know how they used to think that the world is flat? And now we say that the world is round? Well, you know, science gets stuff wrong all the time. Science is incomplete. So, what do you think the chances are that science will come up with the idea that we live in a bouncing tetrahedron? Right? The world is really shaped like a pyramid. Ha! I know it and you don't. Those aren't the kinds of changes that we see with science. We don't see wholesale replacements of models of reality that work well at the scale for which they're intended. When Albert Einstein replaced Newtonian mechanics with relativity, we still end up using Newtonian mechanics to build bridges. We still use Newtonian mechanics to figure out how to get a probe from the surface of the Earth to the clouds of Titan, one of the moons of Jupiter. So Newton's ideas weren't thrown away, they were augmented and refined and clarified. And in certain extreme circumstances, when you're moving really fast or when gravitational fields are really strong, it turns out that Newton's ideas aren't quite right. And when you're building a house or you're playing soccer, presuming that the world is flat is a perfectly reasonable and often necessary thing to say. But if you're navigating across continents or flying in a jet plane, you cannot ignore the fact that the world is round on that scale. It's round on every scale, but we can safely ignore it on almost all practical scales. So the idea that science doesn't necessarily have the final answer doesn't mean that we're going to take the theory of natural selection and throw it in the trash can at some point. It means that we may find that our theories are incomplete or inaccurate in some extreme circumstance, and we'll have to replace them with theories that provide a similar set of effective explanations. I think that's my phone. Somebody can't make it to science talk currently. So whenever anybody tells you that, you know, science has been wrong in the past and we may discover things that are wrong in the future, please remember that we're going to make incremental steps that are ever better approximations of reality, ever better models. And we're not likely to completely throw away ideas that have been proved to work for centuries. All right, some constraints on reality. There are some things that are not likely to exist in the universe anywhere, like an amoeba the size of a house. The way that the internal structure of single-celled organisms is constructed, if they live in a strong gravitational field, they would collapse, and their metabolic processes are not extendable to an organism the size of a house. So if you see an amoeba the size of a house in a science fiction film, you know that this is implausible. It's not going to happen anywhere in the universe that has a pretty strong gravitational field, first of all. And second, an amoeba that big, the signaling pathways that we know about throughout the cell would not be efficient enough to convey information across that size. We know that life will not arise on other planets that are made out of lead, where the life is constituted of lead and iron. They don't have the right chemical properties to create complex molecules, a different kind of organic chemistry. But we do know that carbon is everywhere. So when you're looking for life out in the universe, it's going to be based on carbon. Carbon is so gregarious, it's able to make all kinds of bonds with all kinds of other atoms. And because it's so common, you're likely to see life based on carbon everywhere you go. You're not going to see lead-based life or silicon-based life. There are unlawful acts. There are things that you can imagine doing in science fiction that the laws of science preclude. Backwards travel through time. Now, there's some speculation. There may be a couple of loopholes about this, but most scientists are pretty convinced that backwards travel through time is impossible. Brand new forces and energy. Now, be careful about this one. This is something that pushes one of my buttons whenever I find somebody who's like, well, we're going to use your energy. Well, I studied physics. I know what energy is. So can you explain what you're doing to me in terms that don't use this vocabulary that I'm quite familiar with? Can you talk about maybe I'm emitting a magnetic field and maybe you're interacting with my magnetic field and that causes a torque on some of the cells in my body? I mean, if you presume to tell me things in that way, then we've got something substantial to talk about and to test. But if you say I'm using your spiritual energy, well, I prefer to say emotion, because I have a very clear understanding of what constitutes energy, and I don't like using it inappropriately. I think we make poor choices sometimes with our vocabulary, as I said earlier. Consciousness divorced from matter. So if ghosts really exist, there's got to be some physical manifestation, because energy left to itself takes the form of either the motion of matter or some kind of radiation or field. And if energy left to itself is radiation, it also tends to disperse quickly, typically at the speed of light. So there's no concept of a ghost that would have it made of pure energy. It just doesn't make sense. And I know this because I know basic science. And now you know that too. So if somebody says, I saw a ghost, what's it made of? What is ectoplasm? Is it hydrogen? Is it neodymium? What is it? How can I measure it? Electric fields don't do that. We've got things like ball lightning that can travel, essentially they're plasma balls. And you can imagine plasma balls, but it's really hard to get complex structure that could give rise to consciousness and intentionality out of a plasma ball. Again, basic science can help you get rid of some of this nonsense. The power of prayer. Sometimes people have studied prayer, and they say, look, I don't remember, Harvard, I'm just going to pick one. I'm a Harvard scientist, and I work in the psychology department. And I had 15 undergraduate students pray for a sick pigeon, and the pigeon got well. Well, there are kinds of studies that are like that. But unless you can explain the mechanism by which prayer was effective, how did it change the subject, the target, how did it emanate from the prayers, then prayer probably doesn't have any benefit besides helping you meditate, helping you concentrate, helping you focus your thoughts on a plan of action, helping you decide to do something. Shiloh, my friend who's sitting back at the camera, has shared with me, I don't know if he originally came up with it, but he shared with me this idea that, you know what, I don't want you to pray for me. I want you to get off your ass and do something for me. Shiloh tends to use words like that. So,
originated with P.C. Myers.
yeah. So let's talk about necessary, or these are called necessary constraints. Again, this is another philosophical term that has a fairly specific meaning. When you say that something is necessary, the other idea is that it's contingent. And a necessary constraint means that the laws of science, the laws of reality, the way people really are, for example, we really are selfish. And any social system or political system that denies the fact that humans are inherently selfish is bound to arrive at fallacious conclusions. Right? So there are certain aspects of the world that are necessary, and we ignore them. If we ignore them, we're foolish. It's not even that we ignore them at our peril, because we can't do anything in nature by ignoring the laws of science. And then there are things like contingent constraints. That's a whole other category of things. Here are some things that are forbidden by contingent constraints. Unicorns. So often when people say, I cannot prove there is no God, a typical corollary for that is, I can't prove that there's no such thing as a purple unicorn or pink. Well, in mammals, there is one creature that has one horn, and that creature is a rhinoceros. And that horn is actually made out of tightly compacted and entwined hairs. It's not made out of a bone with skin growing on it, which is what most horns are in nature for other mammals. So what I mean by a contingent constraint is that the way life has evolved on our planet has never shown a body plan that would be related to a horse-like creature, or really any mammal that has a single bony horn growing out of its nose. So am I comfortable saying there's no such thing as a unicorn? You're damn right. I don't have to look in every forest glade to prove to you that there's no unicorn. I can say that the laws of the way the laws of nature have played out on our planet make it incredibly unlikely that there's a unicorn, because we don't see any related species. Dragons. The thing about dragons is they've got 4 legs and 2 wings, so that's a total of 6 limbs. Can you name to me another vertebrate that has 6 limbs that's not, been exposed to radiation or something as an embryo, right? So again, this is a contingent constraint. We can imagine that there are worlds in the universe that have unicorns and that have dragons, and there's nothing in the laws of science that preclude that. But on our planet, the way that contingent history has played out through evolution, we're not going to find that. Gods. We don't know of any physical phenomena that could explain what most people mean when they say God. It's not a plasma ball. When I was a kid, I spent quite a bit of time. I first wanted to be a preacher when I was a young person. And I used to hand out Bibles to my schoolmates and whatnot. And then, Carl Sagan happened. But I spent quite a bit of time thinking about how could the rules of science be made consistent with the preconceptions of Judeo-Christianism. And one of the ideas was that God is everywhere. So here was my train of thought. If God is everywhere, then he has no place to move. too. And if he can't move, he can't act. And if he can't act, that's why we don't see him. See, these are the kinds of chains of reasoning that I pursued when I was in college, trying to rectify my childhood religious beliefs with my burgeoning scientific knowledge. And there are others too. But gods, anything that you can do to explain the attributes, the phenomena, the aspects, the interactions, the dispositions, the routes to appeasement, whatever you want to do, invent it or not, read, convey to me some claim about a God, and science will refute it. And there was actually one person that had a very noble set of beliefs in God. His name was Martin Gardner. Are you familiar with him? So Martin Gardner believed in a higher supernatural power, but he was scrupulously careful to say there is no possible way that this God can be detected. There is no chance that he has an impact on our day-to-day life. It was a kind of rarefied deism, this idea that a God would be hands-off. Pardon me. And Martin Gardner, I respect him because he scrupulously avoiding making any claims about what a God would be that would have any kind of contradiction with physical reality. And what he ended up with was an emotional claim. I need to believe in God. Makes me feel good. Okay, there are lots of people in our culture like that. And I don't have a problem with that so much. When people start saying God is going to protect our planet, or God is responsible for a tsunami, or God moves in mysterious ways, what do you mean by movement? What's mysterious? If God's plan is not like our plan, another thing I wrote in this stuff that I prepared for tonight. It's an old analogy I came up with back in, again, my college days. If I were to flip a coin, and this coin, I don't carry cash much anymore, but if this coin came up with a picture of a person's head on it, and I said, that's tails. Well, you probably decided I was crazy or lying intentionally. What's the difference between that and saying that God's love is different than our love? Love has a clear set of parameters about compassion, about benevolence, about not wishing ill or doing ill against other people. I reject the claim that something that exhibits a set of characteristics in direct opposition to that gets to use that label of good. In fact, I don't believe that there is such a thing as a God in the first place. But you have to be careful about the vocabulary. It's very seductive. And science can give you the tools to realize that you're being seduced. Unlikely acts. I talk about unlikely creatures. Here are some unlikely acts. The rules of physics don't necessarily rule these out, but they're highly unlikely. Travel of people near the speed of light. There's all kinds of things that are true about our universe that conspire to make this exceptionally challenging, not the least of which is that there are hydrogen atoms scattered throughout space. And if we're traveling near the speed of light and we hit one of those hydrogen atoms, it would be like hitting a freight train, potentially. So there are all kinds of complications about having a biologically squishy thing like us traveling near the speed of light, encountering physical objects that we know exist in the cosmos. Visits from aliens on safari. I happen to believe, again, this is a belief, I happen to believe that given what we know about the rules of science and planetary formation and biology, that it is likely that life exists elsewhere in the universe. And I'm comfortable speculating that intelligent life exists elsewhere in the universe, although I have no proof. It seems plausible to me, although I cannot assign it a probability. But the probability that these guys have come here to do all kinds of interesting experiments on farmers in Idaho is very, very low. And I would say that this is implausible. Right? So I can accept the plausibility of alien life and simultaneously reject the notion that they're meddling with us, or that they're going to come here and save us, or that they want our water, or any other speculative idea that lacks a shred of proof. Seeing the future. Now, one thing you might be able to do is move so slowly into the future by traveling really fast, near the speed of light, you can slow your clock down so that you can see what the future is going to be a million years from now. You can live to see what it's going to be like a million years from now. But you can't come back. Remember I said, I don't think you can go back in time? If that turns out to be a law of nature, then this moves from unlikely to impossible. But as long as it might be possible to go backwards in time, this will have to stay in the unlikely category. So I talked a lot about vocabulary problems. Here's an idea. It's easy to say things without understanding them. Nothing can accelerate to a speed faster than light. We probably learned that in college or maybe even in high school these days. Well, what does that really mean? I hope to talk about that when I'm talking about my relativity topic. Evolution via natural selection is true. What does that really mean? I think sometimes the words we choose to talk about a thing interferes with us being able to understand it deeply. Science is just one choice among many for understanding the universe. This is a very easy thing to say, and we hear it all the time. But if you replace science with the humanist preferred term of natural philosophy, then it becomes fairly ridiculous. Because you say natural philosophy is just one choice among many for understanding the universe. That's like saying reality is just one choice for understanding reality. It becomes ridiculous to say it that way. Right? Science, we use the term so loosely and so easily and so ubiquitously that it's lost some of its potency. Science is this process by which we learn about the reality of the universe we live in. And if there's some phenomena that surprises us and that doesn't fit with an existing model, it becomes part of science. So there is no other way of understanding the universe other than the scientific method. All points of view are created equal. Oh my gosh, how often do we see this on the evening news, right? It sells commercials. Well, we found a scientist who believes in global climate change, and we found an economist who doesn't. They both have PhDs. They're going to debate. Commence, right? There's nothing fair about that. There's nothing balanced about it. If you were to put those two camps of scientific thought into a balance, you'd find that the people who believe in climate change would crash through the floor on the balance. And the people who don't, the scientists who don't believe that climate change is real, maybe even some of them are climatologists, they'd be launched up into the moon. The evidence is so overwhelming. But the media goes to extraordinary lengths to deal with both sides. So they do this for natural selection. Well, let's have our politicians do this. Let's have the debate about creation versus evolution. Because I think the debate's important. Right? That's nonsense. That's like debating whether gravity is real. There's no debate. It's not a point of view. It's a real property of the universe. Everything is relative. Poor Einstein. He never said this. I don't. And he certainly didn't believe this. We know that for a fact. This is a terrible misconstrual of the theory of relativity. And it's not true. And again, what I talked about earlier, I think using the word science can be problematic. Natural philosophy, to me, overcomes some of the baggage that goes along with saying, I'm a fan of science. If you say I'm a fan of natural philosophy, there's something that seems more substantial about that, and it's more likely to lead to a conversation. Whereas if you say, I'm a fan of science, you're likely to get, I don't understand science, leave me alone. Right? So I said I was going to push some buttons. Here we go. Please don't throw anything at me. So here are some conservative biases. Unrestricted market capitalism is a cure for what ails you. Well, I happen to be an incredibly passionate proponent for capitalism. And I believe that market economies can vastly improve the efficiencies of the utilization of resources and labor and talent. I'm a big fan of markets and capitalism. But when you put this term unrestrained in front of it, it becomes problematic. Economics is predicated upon certain assumptions, like we were talking about this on the car ride over here. Economics is predicated on the idea that everybody has perfect information about the thing under consideration. It also presumes perfect capitalism, perfect market economies presume that all the costs associated with producing a good or delivering a service are incorporated into the price of that good and service. And we know that's not true. When a factory belches out poison into a river, generally they don't have to pay for that. They don't have to build the payment for that into the cost of whatever they're producing. Markets are not perfect, and the imperfections must be addressed. Adherence to tradition and authority. Right? It's true because I said it's true. Or it's true because Isaac Newton said it's true. Or it's true because the president said it's true. So there may be a certain cachet that comes along with having credentials and having a track record. And we can't all go out and verify everything that we learn. And yet, an adherence to tradition and authority, you should at least have a healthy skepticism for it, especially when they make claims that are inconsistent with things that are clearly facts that we can observe, or that are inconsistent. One of the things that I'm blown away by about science is that the laws of biology and the laws of cosmology and the laws of particle physics, they fit. And there's a couple of things that don't yet fit in our basic understanding of science, but we're working on those. But when you start using dogma and traditional authority to stipulate the way the world works, you see all kinds of things that don't fit. Beliefs. Typically, conservatives deny global warming. It interferes with market capitalism. Poverty, education, the environment, food and medicine, safety will all be addressed by the magic of the market. I don't just believe that that's not true. There's science to back up the fact that markets don't fix a lot of these things. This is provably false. There's no need for alternate energy. It can range from, why would God put us on a planet where we're going to run out of fuel, to there's plenty of oil, and new oil is being made all the time by bacteria in Siberia. Well, that's a scientific claim, and it can be refuted. God or spirits will watch out for us. I kind of talked about that. And they dismiss science they don't like. If something isn't compatible with the idea that markets are pure and perfect and cures for what ails you, then they just reject that. It doesn't fit with their preconceptions and their biases. And they suspect that there's a conspiracy leading to a one-world socialist state. Right? These are common tropes on the right. Here we go. Liberal biases. Natural is best. I have some very dear friends whom I love and respect and engage with in a respectful manner, but they are convinced that this is true, that natural is best. I'm not going to spend an hour talking about it, but let me give you something to think about. Humanity has spent thousands of years developing the technology and the capacity to grow food in mass quantities, to grow food that is more nutritious, to put roofs over our heads, to build lighting and refrigeration, to provide entertainment through video, etc. Our qualities, our respective individual qualities of life have been vastly improved over burrowing in the woods. If you want to live close to nature, that's your choice. I respect that. You're a human being. You have the freedom to do that. I sure don't choose that. I revel in the qualities of the world and the quality of my life that has been enhanced by an understanding of science. And I don't presume that natural is better. It's not going to make me happier. It's not going to improve my or your quality of life. And when we're talking about feeding 7 billion or maybe eventually 11 billion people, we can't do it by living pastorally off the land. We have to be able to mass produce medicine. We have to be able to mass produce food. This notion that natural is best is a fallacy of thinking, and it doesn't rationally and clearly admit that we have had to overcome nature to get to where we are.
You have a question over
Yeah.
there?
Nature, through the process of evolution, has gone through sort of a screening process to create some things that work.
Right.
Whereas human-made objects haven't necessarily gone through that screening process, and so a healthy alertness to problems with these artificial technological things makes sense.
I couldn't agree more. A healthy skepticism and a precaution about unintended consequences is entirely warranted. But mankind took a short grass that grew in Turkey that had 6 or 7 seeds on it.
Humanity, please. It was likely a lot of women involved.
You are certainly correct. I apologize. Humanity, and likely predominantly women, in fact, took that edible grass and through conscious and intentional manipulation turned it into wheat and corn and barley and rice that we know as our common cultivars. We have been manipulating nature, including our food, for thousands of years. And we manipulate nature when we make something like this. I'm pretty confident that there are very few unintended consequences of having created this kind of artifact. If I were to push, so there's a button here that emits a laser light, and if I were to shine that in my eye, then that would cause me harm. If I use it in an irresponsible manner, it could harm me. But I know that, and I know not to do that. I know not to eat this. It's got a lithium-ion battery in it, and I don't know for certain, but maybe it's poisonous. I'm not going to eat that. So we know some of the problems associated with this if we use it inappropriately. I believe it behooves us to understand what could happen when we develop a technology and we might use it inappropriately. So I agree with you in that context. What I don't agree with is that nature knows best. Aldous Huxley, I think, said nature is red in tooth and claw. Charles Darwin, actually Richard Dawkins talks about how if natural selection were the relevant process operating between nation states and individuals, you wouldn't want to live in that world. The survival of the strongest, those who could reproduce the most and the fastest win. I mean, the program that nature has built into life is not what we would consider an ethical program. It's whoever's strongest, whoever's fastest, whoever breeds the most wins. And overcoming that program takes intentionality. Reproductive rights, for example. Right? We have to be intentional to thwart our natural tendencies sometimes. Beliefs, liberal biases, distrust of vaccination. Science has been clear on this. There was one paper that came out, do you remember when it was in? Was it the
field paper in the early 90s?
Yeah, I was thinking it was the 90s. So there was one paper that came out in the UK by a doctor,
Thomas Wakefield,
who said thalidomide, which is a mercury-based preservative that was put into vaccines.
Thimerosal.
Thimerosal, thank you. is responsible for a lot of bad stuff. Well, they tried to reproduce his study and they couldn't do it. It was nonsense.
Well, it was a fraud.
It was a fraud. It was intentional fraud. But just to be safe, they took thimerosal out of vaccines. Just to be safe. And they are. There's a 1 in, depending on the particular vaccine you get, there's an infinitesimal chance that when you take a vaccine, you might catch the thing that you're being vaccinated against. Maybe you get a virus particle that's active instead of dead. But that's unfortunately better than the alternative of having everybody with smallpox. Beliefs against GMO and water fluoridation. We had a debate on GMO last year, and the science on GMO is pretty clear. If you do it responsibly and you're not trying to inject poisons that kill off the people who are eating your food, and why would you do that? As long as you're not trying to intentionally create a harmful poison, if you're very careful and you want to insert a gene to make vitamin B into rice to provide Asian countries with a new and plentiful source of vitamin B, then, or was it D?
A.
Or A, thank you. Please, make it better. Make food that is more nutritious. And the science on this has been overwhelming. And it's not just science from Monsanto, right? Monsanto is one of thousands of voices, including independent studies from universities, that say that GMO is safe. Water fluoridation is another one. Safe and effective.
Scott, Monsanto and others, though, I think, shouldn't object to having these things labeled so that it is possible to monitor and test them. And there has been some real pushback against that.
Yeah, I don't want to get into a specific debate about that right now, but maybe you and Shiloh can talk about that. He's specifically studied it. Liberal biases prefer herbal remedies and organic foods. Again, we've worked for thousands of years to make nutritious, mass-produced food. And even notwithstanding that fact, the requirements to be able to stamp organic on something probably aren't what you think it is unless you've researched it. I believe in universal economic inequality as possible. So here's a little factoid. If you took all of the productivity and all of the wealth generated on the planet by consuming fuel, fuel turns into produced goods and services, fuel turns into food. If you take all of that energy and you take all the products of all that energy and you distribute it equally across every single person in the world, the standard of living will be about the same as people in Nigeria have. That's a fact. We can't avoid that. Now, I'm not saying that that's ethical. I'm not saying that's the way the world should be. I'm not making a normative statement about it. I'm saying that is a positivist fact. And we have to take that into consideration in any scheme we come up with to try and address poverty and malnutrition and inequality in the world. Have no use for traditional energy sources, fossil or nuclear. Well, we got to get energy from somewhere. We can't produce cars and Unitarian churches and laser pointers without energy. We've got to get it from somewhere. And right now, the alternative energy sources should be researched. I applaud all of that, but they're not quite up to the point where they can replace traditional fuels. We can't just switch over today. Dismiss science they don't like. This is the same thing that was on the other slide. If you don't like the science, if the science disagrees with your bias that natural is better, well then clearly it's a corporate conspiracy. Clearly the scientists are being paid off. Clearly the scientists have a hidden agenda. Corporations, after all, are conspiratorial and vile. It's easy to come up with emotional answers to justify ignoring science. And to be truly motivated by natural philosophy, we have to be on guard against that. We face real problems. Social, governmental, economic, environmental, energy, deaths from space, solar flares. A giant solar flare could knock out much of our technology. An asteroid, that similar to one that took out the dinosaurs, may have our number on it already. We got to do something to prepare, to be on the lookout for that. These are real problems. And we also have to protect ourselves from baloney. Carl Sagan talked about a baloney detection kit. Some people use another B word. I don't know doesn't imply magic. I don't know how life first arose from inorganic material. I'm going to be giving a whole lecture on plausible mechanisms, one of which may or may not be true. But just because I don't know how that happened and nobody else in the world, as far as I know, knows how that happened, that doesn't mean that we have to invent a magical explanation for it. Extraordinary claims require extraordinary evidence. Another statement from that Carl popularized, even though he didn't make it originally. And then recognize the hijacking of scientific vocabulary. This drives me bonkers. Quantum healing. You've heard that? Quantum healing. You know, Deepak Chopra. Read one of his books and it's full of baloney from cover to cover.
Energy.
I'm sorry, I did.
Energy is also used.
Right, energy. Right, I talked about that a little earlier. You know, you have to channel your inner energy. What the hell is that? Right?
Well, it's energy.
All right, pinhead ignorance. Dave, can you help me play this video? So why is this important? I want to show you why. Watching pinheads.
Vaccines cause autism. Wind energy is causing cancer. Right-wing wackos? Well, our next guest says these sentiments are alive and well on the left as well. Joining us now in Los Angeles, California, here's Michael Shermer. He's publisher of Skeptic magazine and a columnist for Scientific American. And we want to remind our audience, as we welcome Michael to the program, that you can be part of this conversation. Our producers Naveen Vaswani and Sandra Jonas are hosting a Twitter chat right now. So send us your thoughts via Twitter and use the hashtag AgendaTVO. Michael, it's good to welcome you to the program. And in doing so, I want to just start by reading an excerpt of something from a publication called Science Left Behind, written by Alex Barizo and Hank Campbell. And it goes like this. By the modern era, super-rationalist progressives who once had held an almost religious belief in the power of science to create a utopian future, had now largely left science behind. Lacking an emphasis on objective fact and focused primarily on legislating ideology and fighting anything that disagreed with cherished ideas, progressives became, as we know them today, unscientific, while claiming the mantle of modernity, denizens of a world where science is replaced by feel-good fallacies. Let's get into this. How exactly are progressives, or those on the left, unscientific in their ideology?
Right. Well, first of all, I wrote that column based on that book in Scientific American, largely because for the past 10 years or so, I've been pounding on Republicans pretty hard on their anti-science attitudes, particularly against the theory of evolution and global warming. And I got a lot of mail, saying, hey, what about, people on the other side? They could be anti-scientific. So people were sending me lots of examples. And when I saw this book, I thought, yeah, I should try to be a little fair here and, dish it out to the other side as well, because nobody has a monopoly on truth and nobody's free of political bias for sure, including myself. So it's good to, I think, to sort of spread the skepticism around. And in particular, I would agree with that sentiment you just read there from the book, and just sort of look at the larger picture that, like in that very issue of evolution, for example, there are, of course, creationists on the one side, on the Republican side, who don't believe in evolution at all. But on the other side, there's what I call cognitive creationists. That is, people who don't believe that evolution applies from the neck up. That is, they pretty much think that the mind is a blank slate, almost entirely constructed by culture, by the environment. And And this is simply not true. These evolution wars about the mind have been fought out over the last 20 years. In fact, it was over almost a century and a half since Darwin published The Origin of Species that it was actually acceptable to claim that the human brain evolved just like the rest of the human body, and that the brain as an organ is like any other organ in the body. It evolved for a particular purpose, to solve problems in the ancestral environment. That was controversial all the way up until just recently. In fact, it's still kind of controversial. So that idea, the blank slate, I consider that to be largely an anti-science attitude, and that attitude is almost entirely held by people on the left. Now, I want to make another important point that when people attack Republicans, really what they're attacking is people on the far right, because most Republicans accept most of science. It's the extremists on the right. And on the left, most people on the left accept most of science. And what we're mostly talking about here is the extreme left or what are called progressives, roughly speaking.
And these are the views of, as you can see, we've broken them into 4 different groups. Members of the general public, Democrats, Republicans, and then the Tea Party, that extra special feature of American political life these days. And here are their reviews as reflected by the red and blue bars on climate change and evolution. And you can see members of the general public, 69% believe the Earth is getting warmer, only 57% believing humans have evolved. 81% of Democrats say Earth is getting warmer, 64% say humans have evolved. 49% of Republicans, showing the skepticism on climate change here, believe the Earth is getting warmer. Only 45% believe in evolution. And among Tea Party types, only 41% believe that the Earth is getting warmer, and 43% believe in evolution.
Well, I like to think a GMO is actually God move over, because pretty much it's scientists, messing with nature.
Every farmer that buys a genetically modified seed is doing it for one reason, because they know it's the better seed.
There is so much misinformation right now about this technology that general public is having really hard time to figure out what is really true or what is not.
But God's word is true. I've come to understand that. All that stuff I was taught about evolution and embryology and Big Bang Theory, all that is lies straight from the pit of hell. And it's lies to try to keep me and all the folks who are taught that from understanding that they need a Savior. You see, there are a lot of scientific data that I've found out as a scientist that actually show that this is really a young Earth. I don't believe that the Earth is but about 9,000 years old. I believe it was created in 6 days as we know them. That's what the Bible says. And what I've come to learn is that it's the manufacturer's handbook, is what I call it. It teaches us how to run our lives individually, how to run our families, how to run our churches. But it teaches us how to run all of public policy and everything in society. And that's the reason, as your congressman, I hold the Holy Bible as being the major directions to me of how I vote in Washington.
Science and technology, yeah.
Republican Congressman Dan Rohrabacher of the House Committee on Science, Space, and Technology really doesn't believe that global warming has any impact on the wildfires raging across his home state of California. Listen to what he told constituents at the town hall last week.
Just so you'll know, global warming is a total fraud, and it's being designed because what you've got is you've got liberals who get elected at the local level want the state government to do the work and let them make the decisions. Then at the state level, they want the federal government to do it. And at the federal government, they want to create global government to control all of our lives. That's what their game plan is. It's step by step by step, more and bigger control over our lives by higher levels of government.
David, Beverly Hills, Florida. What do you mean when you refer to the tides, when you ask about the existence of God? Science explains the tides, the moon's gravity pulls on the ocean. Okay, how did the moon get there? How did the moon get there? Look, you pinheads who attacked me for this, you guys are just desperate. How'd the moon get there? How'd the sun get there? How'd it get there? Can you explain that to me? Yeah. How come we have that and Mars doesn't have it? Venus doesn't have it. How come? Why not? How'd it get here? How did that little amoeba get here? Crawl out there. How'd it do it? Come on. You have order in this universe. You have an order in the universe. Tide comes in, tide goes out. Okay, yeah, the moon does it. Fine. How'd the moon get there? Who put it there? Did it just happen? Okay, if we have existence, if we have life on Earth, how come they don't have it on the other planets? Were we just lucky? Some meteor would do this? Come on. You know, I see this stuff, it's desperate. As I've said many times, it takes more faith to not believe and to think that this was all luck, that all this human body, the intricacies of it and everything else, all luck, than it does to believe in it, indeed. Here you go.
It's funny because on this question, I think I would probably be more with conservatives because we've heard a lot about the swine flu vaccine recently. Yeah. Conservatives always say about healthcare, especially, you know, you're going to let the government run healthcare, they screw everything up. So why would you let them be the ones to stick a disease into your arm? I mean, I would never get a swine flu vaccine or any. I don't trust the government, especially with my health. Yeah.
This guy is a journalist from Britain that was a founder of some anti-GMO.
Now, my lords, ladies and gentlemen, I want to start with some apologies which I believe are most appropriate to this audience. For the record, here and up front, I want to apologise for having spent several years ripping up GM crops. I'm also sorry that I helped start the anti-GM movement back in the 90s and that I thereby assisted in demonising an important technological option which can and should be used to benefit the environment. As an environmentalist and someone who believes that everyone in this world has a right to a healthy and nutritious diet of their choosing, I could not have chosen a more counterproductive path, and I now regret it completely. So, I guess you'll be wondering, following on from what Mike said, what happened between 1995 and now that made me not only change my mind, but actually come here and stand before you today and admit it? Well, the answer is fairly simple. I discovered science, and in the process, I hope, I'm becoming a better environmentalist.
Dave, could you switch it back? I just have a couple more slides.
Who was that?
So that was a journalist and an activist from the UK. He writes for The Guardian and other papers in the UK. His name is Mark Lynas, L-Y-N-A-S. And he was a loud voice that played a large part in getting the European Union to ban GMO crops. And you can look all this up on Wikipedia. This isn't just my opinion about stuff. You can look up his name. You can you can watch that whole video, etc. But I wanted to show that why is a scientific education important? It's because of things like that, and it's across the political spectrum. Being ill-informed about science has consequences, and when we try to move from making statements about what is to what ought to be or what we ought to do, if we don't have a good grounding in what is plausible or what is possible, then we're likely to make terrible mistakes or fool ourselves. So what's the alternative? Right? I mean, I know that this may have a little shock value, but I really do think that a rejection of science is a rejection of really the only path we have available to make the world a better place for billions of people. And when you revert to dogmatism and biases and motivations based upon emotion and bigotry, then you're going to oppress anybody who doesn't agree with you. Science is a highly democratic process. We award prizes for people who come up with new ideas. These people don't reward new ideas. Which kind of society do we want? So who am I? I told you I'm not a professional scientist. I'm an avid science learner, and I hope I'm becoming an ever better science communicator. And like I said, anything I've said tonight, if you question it, if you disagree with it, feel free to look it up. And feel free to talk to me and argue with me. And here's another list of all too common baloney. You might find something that you like up here. I'm not going to presume one way or another, and I'm not going to ask for a show of hands. And this is not a complete list. So that's it. That's why I think science is important, because I think it is the best and the only plausible way forward to improve our lot in lives and those of our fellow citizens. And I thank you for your attention. And I don't know how late you want to stay, but I'm happy to take questions.
Was Bill Maher being funny, or
no?
No, he's serious.
He was being serious in that clip?
Yeah. Yeah, he's been a vocal anti-vaccination person, and he's begun to moderate his views a bit. Michael Shermer, the guy who spoke first, he originally held a position that was highly skeptical of anthropogenic global climate change, and he has since changed his mind. So one of the things I hope to convey with that last clip is that it's okay to change your mind. I've done it myself many times. We usually think it's a noble characteristic. How noble would it have been for George Bush to stand up and say, instead of, I've got my ideology and I know what the truth is and I'm going to pursue it. What if he'd have said, I was wrong. And I ask for your forgiveness. And we're going to try a different track. What? How different would he have been perceived? There's no reason to feel bad about yourself for admitting that you held a belief that was not consistent with reality.
I have not seen a politician who make mistakes.
Yeah, I know. There probably are some, but we don't know. Yeah.
I'd like to take kind of a meta-humanist view on the whole topic that you brought up. And at the risk of sounding very foolish, I'm going to propose this.
Okay.
And I thought of this while you were talking. So, Rabbi Kushner, whom we probably all know, the Jewish theologian who wrote several books, made an interesting statement that one might almost consider heretical in religion. And he said that if there were no people, there would be no God. Mm-hmm. And I thought it was well argued, And I'm thinking to myself, perhaps if there were no people, there would be no science. And the one thing that both views of the world have in common is their dependence on people, which makes us the common denominator between two seemingly irreconcilable views of life. And I'm thinking, had you chosen to be a minister instead of a scientist, we could be in another room with the smell of coffee on a Wednesday evening and in uncomfortable chairs, and you would create a different persuasive argument, which we, the audience, would likely believe because we are predisposed to do so. And it occurs to me that both the you scientist and the you preacher would create an environment of truth as long as you had a willing audience.
So I think that is eloquently said, and I appreciate you sharing your thoughts with us. But I disagree with it.
I'm not surprised.
And the reason I disagree is because I'm going to use one example, the Large Hadron Collider in Switzerland and France. There are Muslim scientists, there are Christian scientists, there are atheist scientists, there are Hindu scientists, there are African scientists. I don't presume to know all the religions and all the cultural backgrounds of everybody who worked there. But they don't agree on who's up in the sky. And they don't agree about what holidays to celebrate and what rituals to practice. But they all agree on electrons and protons. And if people didn't exist, and there is intelligent life elsewhere in the universe, they're also going to know about electrons and protons. They're going to know about market economies and the efficient distribution of resources. there are aspects of the natural world that may be tied up in observation, and we'll talk about a little bit of that with quantum mechanics. But the thing about scientists is that anybody can agree on it. The thing about religion is that everybody is likely to have their own interpretation and point of view, and that makes them horribly different.
I don't have a question but a comment. The reason that I avoid GMO foods, at least some of them, is for economic reasons rather than, I'm sure they're fine, but the large agribusinesses have been known to bully small farmers on whose land their genes happen to have blown through the pollen.
So that's actually based on a false story. My friend Shiloh, when he was preparing for the debate last year, researched that extensively, and he came into it unbiased. I swear to you, right? And he researched the legal case. He researched the facts that were determined during the legal case, and that particular example is largely untrue. It's not consistent with reality.
The one in Canada?
It was a single case against a Canadian farmer who found the seed on his farmland.
Right.
3 years later, Monsanto sampled the seed and
Sampled
found
his crop.
His crop,
Yeah.
and found 97% of his yield was their seed. The only way he could have accomplished that was by preferentially harvesting the resistant seed and planting it the next year.
He stole it.
So
He stole
He did steal it, okay.
He absolutely stole it. The year that it happened, he reported it, and Monsanto did nothing.
Ah, okay.
So again, try to be skeptical about these things. We hear claims in the media, both sides of the story. Sometimes one side is true.
There was a farmer down in Indiana that harvested his own seed and planted it, and Monsanto came after him too. And he lost in court.
I don't know the details of that. I'm not willing to say, without knowing the facts, what really
Well,
happened.
he had planted the Monsanto seed
Oh, he had?
the year before, and he harvested it, and he did not want to go pay the price for the seeds, and he wanted to use what he had harvested the year before.
So there's all kinds of complex issues around intellectual property rights. Can you own a genome?
But Monsanto does.
Right. I understand that, and certainly not now am I taking a position on those intellectual property right issues. I'm just taking a position on the science of genetically modifying crops. Ownership rights, ownership of a piece of a human genome or a corn genome, that's a separate issue that I think we have to sort out very carefully.
I think it was determined that if it's natural, you cannot patent it. But
Right.
if you create your own gene, I mean, if you make artificial gene, then that's patentable.
Yeah, and I'm not sure that's fair.
Like U.S. law at this point.
Beth?
To change the subject, I'm a retired English teacher, so I applaud your use of explorational language. And I have just a very brief comment. It is really very, very hard, almost impossible, to prove a negative. And that's why humanists and fellow travelers have so much difficulty, I think, to try to pursue the logic that requires them to, first of all, identify what they are trying to disprove and then trying to disprove it. This is the problem atheists have.
Right. Well, I hope that my example about the unicorn broached some of those topics. Typically, when people get to the point that you can't prove that a unicorn doesn't exist, most people admit that that's true and give up. I don't think you have to give up, because evolution is real, and evolution hasn't created anything like that. And there are other ways to approach the problems obliquely.
But there is a mammal with a single tusk.
The narwhal, yeah, and that's a tooth, not a horn.
You are making the distinction between science and naturalistic philosophy, right?
I don't think that in my mind they mean the same thing, but I think one is a richer concept when communicating than the other.
Right, and I'm personally a little skeptical that the second term is going to catch on. And I wonder if you think scientific method as an alternative to science might be a more practical way of making the distinction that I think I heard you trying to make.
Yeah, I think people get scared by the words math and science. And so I like natural philosophy. It's the old term for science. And in some sense, I think it's a richer term because we've compartmentalized science and we bring our preconceptions into it.
Well, science gets used kind of in it's used for two things. That one of them is the body of knowledge that's been, science says this, we know this. But then it's also a method of learning things about the world to keep us from fooling ourselves. And those two kind of get muddled together in that one word that science is this. So there is some terminology problem with that the two get confused. One of them is the process, but the other one is also the body of knowledge that we've accumulated.
Right. I also have, as some people in this room can attest, I also have difficulty with using the vocabulary of religion in the context of something that isn't supernatural. For similar reasons, and I think it's very loaded with baggage.
One problem I have with philosophy is it sounds like it's more opinion as opposed to actual.
Yeah, and a lot of wrestling with semantics.
Right.
Yeah. Somebody else?
Yeah. Isn't most corn, almost all corn these days in the U.S. GMO?
Yes.
That's what I thought.
And you've been eating it for 20 years.
There was an article I read in the last paper about Chinese trying to steal. I forget what it is. They said 1 every 100 plants is the base point that they can go back and engineer their own corn.
Really?
But basically they're trying to leapfrog 50 years of development by, if you want to say Monsanto, it took them a long time to get to where they are.
Yeah, it's a very fun.
And we've gone from 100 to 200 bushels an acre.
Right. The idea of intellectual property around genetics and stuff, it's not something I've delved deeply into enough to have a clear opinion.
That DNA is shot into the corn nucleus with gold pellets. A lot of people know that. Originally, that's how they inserted the DNA. Now they can use bacteria, but not every plant will accept bacteria into its nucleus. But the original GMO in corn was inserted into your nucleus by putting the DNA on little gold pellets.
Can I use that in my talk about gold that I'm going to
I'll bring you a book next time that shows the process.
I mean, basically, evolution is genetic modification, right? I mean,
Yeah.
since bacteria came and modified themselves and created,
And so is artificial selection, selecting the 5 stalks of corn out of your field that you think have the characteristics that you like the best and planting those preferentially.
So there's been genetic modification all along, natural and artificial selection, but I think that's maybe a term that got put in when really, to me, when I think of GMO, I think of taking genetic structures from, let's say, a fish and deciding to put it into corn because it gives it antifreeze or something. It lives through weather better.
And maybe that means North China now gets a bumper wheat crop.
Right.
One of the things I didn't mention is that whenever you presume to make other people's decisions for them, that can be really problematic. So when we presume to say that children should not be able to work in Nike factories in Bangladesh, considering the alternatives they have available in their economy to better their lives, that decision may be catastrophic. They may have to go sell their bodies on the street or cut off a hand and beg.
And in fact, they did.
So anyway, when you make decisions for other people, there's I can't remember the quote, but I didn't write it down for this talk, but there's a quote from somebody in a developing country that says, you people in the West get the luxury of debating whether this is good or evil. My people are starving. I want food. And if this helps me get enough food to feed my people and keep babies from dying, then let me choose that. Let me make the choice. Don't presume to choose for me. Anyway. All right.